Hi, folks. So as you just heard, we're going to do this talk after lunch, but Christian didn't show up, so we're going to, there was some miscommunication, probably my fault. We're going to do this. We did not actually finish the slides, but we'll get it through. So, for example, this slide was going to have more information than just our name, but it does the job. I'm Chris. And this is Alban.
I'm Alban. Hi, I'm Alban.
And so we both work at Microsoft. We came over in the acquisition from Kinfolk, and one of the projects we worked on at Kinfolk was called Inspektor Gadget. And one of the great things actually about the acquisition is that we have been able to do a lot more work on. We've been able to do a lot more work on Inspektor Gadget, and we're actually basically here to present that and how, and how you use it, how you build on it, etc. So the brief overview is I'll give history, intro, a little bit of history, and we'll talk about Inspektor Gadget as a tool, and we'll talk about it as a framework, and we'll talk about looking ahead a little bit. One of the things I do want to point out, though, is that everything we talk about here is a work in progress. This means that if you download Inspektor Gadget right now, you'll have a slightly different experience. It's similar. It's still eBPF programs that you can run and do systems insights, except we're making it a lot more versatile now. And so when we give demos, we'll actually include the branches, we'll include PRs and issues that this is all built from. So if you want to follow along and learn more, you can. And so we are looking at having the work that we're demoing today initially finished around mid-November. Nothing is ever finished. Details may change along the way, though. So intro and some history. Inspektor Gadget is a set of tools for Linux and Kubernetes for using eBPF programs. So we call these eBPF programs gadgets because it's not only eBPF programs. It's we'll get into that a little bit later, but it's eBPF programs plus some metadata plus some user space execution code, and it's also a framework. So you can't only use this. I think we need to come closer together. And so it's also a framework. So you can actually build tools on top of it. You can consume it. We're basically a gadget is a OCI container, and the way we've built Inspektor Gadget, you consume it by the API, by even consuming it as a library. But we'll talk about that in a second and give demos of that. So like I said, we started this project in 2019, and we actually demoed it first at All Systems Go 2019. It seems like forever ago. And we initially wanted to bring eBPF and BCC into the Kubernetes world. So when you run eBPF programs, it has no concept of a cluster. It just gives you information from the kernel. And so what we wanted to do, so that means that initially it was only supporting Kubernetes. Now we support Linux host and we support Kubernetes, both. And so we discovered along the way, though, that we were essentially building a framework because we had a bunch of different eBPF programs and they were all working a little different. So we created this kind of framework around it. And what we're going to talk about now is this transition from having these built-in eBPF programs. For example, when you install Inspektor Gadget now from a release, you get basically all the BPF programs and you can choose which ones to run. When the experience we're going to be presenting here is more of a container-based thing where you can pull down, you can also bundle different things, and so you can kind of create it the way you want it. Makes it very flexible. So why are we doing this? Basically, many projects leverage eBPF, and they do very common things. They enrich the kernel data. This means they map the low-level stuff that the kernel sees to the high-level stuff that you see in Kubernetes containers or systemd services and units. They basically filter data based on these higher-level primitives, saying only show me stuff, for example, in this Kubernetes pod. And they send data, for example, to a time series database like Prometheus or a log server, or they expose the information via API. And a lot of times you do some post-processing in user space. And so what we're doing with Inspektor Gadget is we're trying to support all of that so that some of the projects that people have now based on BPF can be as simple as some gadgets and a configuration file. And so we want to really make sharing eBPF programs very easy, and we want to support many modes of running it. This means having interactive, so you can use it on the command line. You can put it as run it as a daemon in a systemd service, and talk to it by API, or you can include it as a library. And we want to support many environments, at least the ones that Linux supports, which is, where Linux runs. So under Kubernetes, containers, Linux host. So the tools that we have before we get to the demos, to give you an overview, is we have IG. This is not an Instagram client. This is actually the command line tool that you use on Linux. It's when you want to use it it supports both interactive and daemon mode. And it's also used for building, pushing, and pulling Gadget images, which we'll show in just a second. And then we have kubectl Gadget. This is just a kubectl plugin, and that takes care of deploying Kubernetes Inspektor Gadget inside of a Kubernetes cluster and the interaction. And Gadget CTL is actually very similar to kubectl Gadget as far as code, but it serves its purpose as to communicating with IG when it is in daemon mode. So what is a gadget? It is an OCI image, and it contains eBPF programs. It can be more than one in an L file. User space modules for optional post-processing or user space processing, and metadata to give us some more information. For example, what kind of export options it supports. Does it support Prometheus, or is it more of a logging tool? For example, we're building some plugins for a sister project called Headlamp that's basically a Kubernetes UI, and that should give you automatic visualization inside of that Kubernetes UI. Of course, you can also send it Prometheus and graph it with Grafana. And gadgets are a deployable unit, and they are a shareable unit. So I'll hand it over to Alban, who's going to explain this, and then do some demos.
Thanks. So this diagram shows how the IG process can push and pull images on an OCI registry. That could be Docker Hub or any others. And the gadget contains some metadata, eBPF programs, and eBPF maps, and optionally user space module. So I will start with the demo.
Bigger.
I'm trying to make it bigger. 1 minute. Is it big enough or bigger?
Good.
It's good? Okay. So I put a text file to remind me the steps. So I start with a fresh state. So I didn't use Inspektor Gadget on my laptop so far. And as you can see, the list of gadgets are empty. And I have some gadgets in this gadget directory, like TCP connect, which is my first gadget here. And so what I'm going to do is to build it with this image build command and specify the OCI image name that I want to use. So in this case, I use the Azure Container Registry, but I could use any others. So when I compile this, then I should have a new image in my list. And and then I can just run it with this command. So in this command, I just specify the name of the OCI image, and optionally, I can use some parameters. In this case, I only want to see the container's name in this way. So now it's waiting for events that I should get from eBPF. In another terminal, here, I will make it bigger too. 1 second. Here I am inside a Docker container where I can run some commands. So it should generate some TCP connections. Oops, sorry. That's the demo effect. It doesn't work as I wanted. Oh, sorry. I used the wrong terminal. So let me start again. Here I am really in my Docker container. And I generated a couple of TCP connections for HTTPS. So that was the first demo about showing how I can build a gadget from the source and push it to a registry, and I can pull it too and run it.
Yeah, so these are basic functionality that you would be familiar with from any container runtime, and we definitely want to make that a familiar experience. That's obviously intentional. We also want to reuse the infrastructure that's available from containers world. But that's actually not, there's quite a few, actually, at least 3 eBPF projects I know that do this. One of them is a Bumblebee, which we're initially looking at. But we're doing a lot more stuff, and we're going to actually talk about that. And you can see the slide is not finished because it only says running here. I intended to write more. So we want to see how we run Inspektor Gadget. One thing is when we're running host, basically you can just run the IG command, right? But this IG binary then loads the BPF programs in the kernel, or you can run it inside of a container with, for example, that command. You can also run IG inside of a system D unit, and in this case, you can use Gadget CTL. You can actually, you don't have to use Gadget CTL for this. You can actually just initiate it with the commands, and it'll run that specific gadget. But if you want to actually make it interactive, you can use Gadget CTL to load different things, and that's very similar to how Docker daemon works. In Kubernetes, it's a little more complicated because we want to run on all the nodes, at least in the standard mode. And so here, you just run kubectl gadget deploy, and it'll put this basically gadget pods on each node, and then you can do the standard queries, and you basically get aggregated data from all the nodes. But recently, Kubernetes world has introduced the debug node command. And what this allows you to do is basically go straight to a single node. So the way this is different is that it only, you go into a very specific node. Inspektor Gadget, this is like a perfect use case for Inspektor Gadget. And so, we quickly added support once this became available in Kubernetes. So it basically allows you to run, using the kubectl command, Inspektor Gadget on this single node in the supported way that the Kubernetes community provides. But when I said, we have several projects that use container-based, basically putting BPF programs in containers. But a lot of those are very basic. They only use that mechanism. What we want to do is basically provide a lot of these, like I said before, there's a lot of this functionality that we build around this. And so one of the main things is enrichment. Enrichment basically, the information that BPF programs get is not very useful to the naked eye normally. We understand systems based on higher level concepts generally. Kubernetes pods, systemd units, container runtimes, etc. And so what we do is we take that, we map it, and we present it in a way that is understandable to people familiar with those systems. And we also allow you to filter in those. And so I believe we have a diagram here, and then we have a demo, so I'll hand it over to Alban.
Thanks. So this shows how it is implemented. On the left, we have the eBPF program that doesn't know whether it's run on Kubernetes or on systemd units or otherwise. And it only gives to user space events. And events can include some low-level data like mod namespace, cgroup IDs, or things like that. But it doesn't know about Kubernetes pods, Kubernetes namespace. And the way you interact is we have the Inspektor Gadget process that can connect to the Kubernetes API server or to container runtime, container managers like containerd, runc, or to systemd to get the list of services or containers that are running and find out some level mod namespace ID or cgroup ID to put in a eBPF map. So the BPF program can consume this information and know how to filter, not to look for events only from this cgroup, for example. So that's how filtering is done. On enrichment, that's very similar. The eBPF event contains the cgroup ID or the mod namespace ID, and that's enough for Inspektor Gadget to find out, oh, this is the mod namespace ID for this container. So Inspektor Gadget is able to enrich the event with additional metadata. So let's try a demo now. Okay. Okay, so I prepared this demo where I will build another gadget that does some trace some DNS packets. So I build it, and I will push it to the OCA registry, and then list it. So now I see it's available in my locally. Then I will run this on Kubernetes. So I have a mini kube cluster on my laptop. So I use kubectl gadget to run this DNS gadget. Now it's running, and hopefully when I go to a Kubernetes pod here and do some connections to Wikipedia, I get some many different DNS packets. So maybe I can make it smaller if it's more readable. And you see the enrichment, because here you see both not only the IP address, but you see it's coming from the pod, P, or it's coming from the Kubernetes namespace default on the Kubernetes pod shell 01. And same thing for the destination IP address, it's converted to this logical representation. So the DNS packet is going to the kube DNS pod. Okay. I have another demo about systemd. So first, I will demo that on the trace open gadget, which shows all the open system calls. And I have this show systemd flag. So stop it. I got some events like, okay, I have this upower.service systemd init that opens some file here. And you see this enrichment that Inspektor Gadget was able to find the systemd init by connecting to systemd over the dbus API and get the link between cgroup ID and logical names. Okay, and it can be useful for debugging. For example, here I can run a new systemd init using systemd run. I will do it in a different shell, a bit bigger. So now I have a new systemd unit running some bash script, and I should be able to trace only this one. I pass the flag SD unit, and now you see the script. I can see which process is opening which file and so on. Okay, so that was a no, not this. Yes, that was a demo of enrichment on Kubernetes, but although on systemd.
Thank you, Alban. Now we're going to talk about user space processing, because you can't do everything inside of BPF programs or the kernel. I think, as people know, there are safety, there's safety, what do you call them? Well, losing the words.
Sandbox?
Yeah, they're sandboxed, there are certain restrictions you have, and some things you just need to do in user space. And so we provide a mechanism, and this actually just, Alban threw this together like a couple weeks ago first, and we decided to do this user space processing in WASM because one of the things we wanted to be able to, people to do basically what they needed, but we wanted to have a sandboxed and controlled environment. And it also allows us to support multiple languages, which we'll show in a second. And so what we have planned in the future is very common things we should provide an API for, and we can use that, make that in a language agnostic way using WebAssembly procedure calls. And so now I'll hand it back to Alban.
Yes, so this diagram shows the flow of events from the eBPF program going into eBPF ring buffer map, that's an eBPF map, to the RG process. And then this struct, this data structure, can be passed to a WASM module by calling WASM method call on there. And then this WASM module can enrich it to add additional information. And I will use this example on the DNS gadget. As you might know, the DNS packets on the network follow RFC, and it's not the domain name is not with a dot notation like wikipedia.org. It's encoded in a different format, and that might be difficult to parse this format and translate it into the human readable string. So this example do it in WASM by getting the raw encoding from eBPF, and then the WASM module will decode it to a human readable string. So let me go back to the demo. So I have two implementations of this WASM module. One is in Go and was in Rust. So the first one in Go So you can see that's Go code, and there is a function that do some string manipulation, adding a dot between the component of the domain name, and so on. And as a debug, if it is wikipedia.org, I add a log that say, okay, this was written in Go. And the Rust module is doing exactly the same thing, but it's written in Rust. So you see it's a function in Rust, does some string manipulation, and then if it is wikipedia.org, then I add a log to say it's implemented in Rust. Okay. Oops, sorry. So I have 3 versions of the gadget. One without weather module, one with Go module, and one with Rust module. So I will compile all of them, push them on the OCI registry, and then use it. Okay. So if I look at my list of gadgets, I should have 3 versions. I will run the first one. And then in my Docker shell, here you see the name column. It doesn't show anything because it didn't manage to parse the string because that's not a human readable string. Oops, sorry. Let me run the second one, the second version. So that's implemented in Go with the WASM module implemented in Go. And then when I do some connections, here I see the well, first I see the name, which is correct. Okay, if I put it on a smaller screen, maybe you will see the full string, but oh, that's too fast. Okay, now you see the full string, and you see the log message saying it's implemented in Go. And then the last one, and do some connections, and here you see the WASM module was implemented in Rust. So this shows that you can write your modules in different languages, Go, Rust, and others, to put it in your gadget and to modify the events you get from eBPF.
Thank you, Armin. So one of our goals is not only to allow you to, basically use container mechanism to create gadgets and then use this tool interactively, but we want you to actually be able to build products on top of it. And so for that, we have several options. You can, start IG binary and just parse the JSON output, which, is completely okay. And then, the other thing is you can start IG as a daemon or deploy it inside of Kubernetes, and you can communicate with it over gRPC through the API. Or what is interesting for quite a few projects is basically importing IG as a Go package and basically using it in your Go project. And so we have one user, Kubescape, which is a CNCF project. And I should have mentioned, actually, Inspektor Gadget is also a CNCF project. It was donated in the last few months. And so, that's a new development. And so one of our fellow CNCF projects, Kubescape, is actually using Inspektor Gadget for their BPF needs. And they switched basically from Falco to Inspektor Gadget because they wanted basically some additional functionality, some more flexibility. Because Falco, if you don't know, it's basically an engine for creating rules where it can signal alerts. And so they have a system for that. Falco is definitely a great tool. In fact, we have an example that we'll show in a second, which is basically a Falco plugin which allows you to use Inspektor Gadgets as a source for these rules. And so I think that demo is now.
Yes, let's see if it works. Okay, so I should have a Falco pod running. Yes, it seems to be running. And I want to show you the configuration of this Falco pod. So in this config map, there is plugin section which said, okay, I have this plugin named libfalco-plugin-ig.so. So that's a dynamic library that is loaded by the Falco process. And this dynamic library include, it is written in Go, and it includes the Go package from Inspektor Gadget. And then I have a low battery, but that should be enough for the talk. In Falco, you can write Falco rules to say, okay, if I have this event, make it bigger. If I get an event with this condition, then output some alert with this message on the priority, critical, or information, and so on. And what I did as a proof of concept is to just use the trace exec gadget, which give an event for every new process, and feed that to Falco, and then I should get some alert from that. Let me look at the logs from Falco. Okay, so during the course of this presentation, I ran many commands. So there was a lot of alerts for each of them, and those alerts come from events coming from Inspektor Gadget. Oops. You want to go and show that? Yes. So another output for Inspektor Gadget, I show you. We can show a view on the terminal in columns. We can show the JSON, or we can show the YAML. But we can also output in Prometheus. So we have a Prometheus endpoint that Prometheus can scrap the data to generate graphic, for example, here. And what I have here is the DNS gadget generating Prometheus metrics. And I can see here for different pods how many DNS packets were detected. So, for example, well, it's not so interesting because it's a bit flat, but there was about 100 DNS packets on this pod, for example. So that's it. And the labels are configurable. Okay.
Yeah, so that slide shouldn't be here. Like I said, we didn't have time to tidy this up. But basically, before I get to the kind of wrap up here, which we'll have to do because this thing, I think this was the laptop that we used in 2019, so the battery life is not that great. So basically, I hope you can see what we're trying to do is basically, a lot of people make eBPF programs. We want to make that actually, so when you create it, other people can use it very easily in a lot of different ways. And so that when you're looking to do something with eBPF, you can say, oh, is there a gadget already for that? And you can use all this different functionality with this enrichment, with the API exposure, sending to Prometheus. That'll all just come, in the box. So on top of the stuff we presented now what we're also, currently we have this kind of inherent bundling because when you deploy Inspektor Gadget, you get all these things together. One of the things we're doing looking forward is we're looking at ways to bundle existing gadgets because, if you have a product that you're building, you might say, I want, these 5 gadgets, and that's what I want to define my project. And so, you can basically have a bundle as a single deployment unit. We're also looking at basically aggregating data from multiple nodes outside of Kubernetes. So we have a cluster concept outside of that. And also, we need to document all this so that you know how to build gadgets and you don't have to go into the PRs and everything for this. And so, yeah, I think we made it. And we have a list of the demos, but you can see those there. Yeah, I think we can take questions. And hopefully we can provide answers.
Any question, folks?
Hey, I just want to know about this Falco tool that it also has eBPF packages that you can actually observe the internal. So where do you guys stand with what you package as eBPF versus what Falco provides? Question number 1.
Yes. So first, this is a proof of concept, so we don't exactly know where it is going. But one difference is that Falco gets events from eBPF or the kernel module, but it gets events about system calls mainly. So, but with eBPF, you can do more things than just getting the list of system calls. You can add a kprobe on any kernel function, or add a socket filter to get packets from the network. And those are the things that Inspektor Gadget do. In the future, we can do uprobes to trace some specific user space process and so on. So we can define gadgets in a specific way to trace maybe a specific vulnerability. And we can feed this information into Falco and write rules which are not only about system calls, which Falco can already do, but about other things as well.
You had a second question.
Yes, maybe third. What do you guys think about adding open telemetry support for the output?
Oh, the stuff we're building with Prometheus is actually based on the open telemetry project. So the initial destination is Prometheus, but it will also have open telemetry support. So yeah. Yeah, so I mean, the basic thing we're trying to do with these kind of integrations and why we do these POCs is because, you know, if you create a gadget, we want it to be, you should be able to use it, like, it creates more value for you to create these if we have integrations everywhere. And, you know, it makes those other projects like Falco more flexible if you can just say, okay, let's not build this into the project because it's not part of our focus, but we might want to have that functionality, and Inspektor Gadget can provide that. Yeah. More questions?
So for the eBPF part, are there certain kernel version requirements, or what, like, in what format the eBPF program is in the OCI image? It's compiled, I presume, right? So can you run it everywhere? Probably not, right?
Yes. So there are several questions. The format in the OCI image, it's a ELF file. So that's an ELF file containing different sections, one for each eBPF program. There are some sections for relocation and some about BTF, which is a BPF type format. And that includes the data which is necessary to have a compile once, reuse everywhere thing. So it should be compatible with all the kernels that have core enabled or BTF enabled. Which is nowadays good enough. In the past, we had some other gadgets which didn't use BTF or core, and that was based on BCC, supporting older versions. I don't know exactly which kernel version, and although some gadgets use specific features, so there can be different requirements for different gadgets. We have other experiments with BPF trace, which is not compiled in ELF in the same way, but we write a script based on awk, and then that's compiled directly with the link with LLVM to compile into some BPF bytecode and use that, and we have that as a prototype in Inspektor Gadget.
So if you have new enough kernel with BPF, it should work.
Yes.
Yeah. Yeah, the question was, we have a BPF program, which kernels does that work on? And the answer was, but generally, we've basically done the plumbing, so it'll work pretty much everywhere, reasonably. But actually, one of the things I should have put in the look ahead thing is that we, like Alvin says, we support BPF trace. That's actually built into Inspektor Gadget right now, but we don't have the enrichment, because there's some work we need to do that. But, you know, in the future, what we want to have is a fully enriched support for BPF trace, which means you don't even have to ship with a BPF program. You could just have in your config file the script, and then you would be able to use it, you know, like that. So, yeah.
So hi, thanks by the way for the talk. You chose an ominous name for your project, considering that from a security perspective, explode gadgets and eBPF go hand in hand. Every single time we have a new Intel or AMD vulnerability or new version of Spectre coming up, the very first mitigation is turn off eBPF. Do you have in mind some ways to get out of that bind? For example, I don't know whether the current support these days signing eBPF module, or maybe fuzzing eBPF modules such that they can be less predictably used as gadgets from an exploit perspective?
Yeah, that was a long question. I'm not sure if I can repeat it. It was about security around Inspektor Gadget. Oh, you got the mic. All right, good. Yeah, I can answer on one level, and I think you can answer on another. First of all, one of the things we've restricted ourselves to, and it's not necessarily something that'll be in the future, is that we only run BPF programs that are observing. You know, we're not changing network paths and things like that. But yeah, I mean, that's as a goal of the project is currently we're focused on observability, not like, you know, changing the system. But maybe, Alvin, do you have more to say about that?
I just wanted to mention that to run the BPF programs, we need capabilities with capsys and others. So in practice, the Inspektor Gadget process is running with full privileges. So that's in practice that can be. You need to be admin on the machine or on the cluster to be able to run it. At the moment, it's like that.
And I can help on the second question. So on signed BPF, it's been talked about a lot. As there were many proposals. Things are slowly moving forward, but I don't think there's any solution yet. But it is being worked on for signed BPF.
Yeah, I mean, we try to stay in the cutting edge of this and make sure we're current. I mean, like, for example, the work about working on multiple kernels, you know, the lead engineer on that, Mauricio, he was involved in a lot of that. So, you know, we're keeping our eye on this, and yeah.
I think we're out of time, so let's thank the speakers.
Thank you. And I would like to say thank you for, and apologies to Alban for throwing him into this. So, you know, we found out we were not going to have this slot filled. So I was like, Alban, let's have the talk now.
You did
and
great.
So, thank you,
great.
Alban.
Next talk in 5 minutes.